Potential dividers, level 2. Right. Okay, this is one where I'm allowed to set the values of the resistors. And I've got to make the voltmeter read minus 989 microvolts. The fact that it's minus doesn't really cause a problem since the voltmeter is this way round. It's measuring this voltage here above that voltage there. So a reading of minus 989 microvolts would mean that this point up here needs to be plus 989 microvolts. So we have a potential divider, which is 10 millivolts at the top, going through a resistor here, which I'll call R1, and that gives me a voltage of 989 microvolts there, going through another resistor at the bottom, which I'll call R2, down to ground. And it's the ratio of these two resistors that's going to be important. It doesn't actually matter what the absolute values of them are, as long as the ratio is right, I will get the right voltage there. So to save time, I could just leave one of these resistors with the value that it's got and calculate the other one. Let's have a look. If I leave this one, R2, as being 1K, then I can work out the current flowing down through here, and that would just be 989 microvolts divided by 1K. And that must be the same as the current flowing down through here. So the voltage across this resistor here is 10 milli minus 989 microvolts, and the current through it is 989 microvolts over 1K, so the resistance there must just be equal to V over I, which is 10 milli minus 989 micro divided by the current, 989 micro divided by 1K. All I need to do is work out that, and that should give me my answer. Well, let's give it a go. 10 milli minus 989 micro divided by 989 micro divided by 1K. 9111, so 9111, that should be close enough. Great. Let's try another one. This is very similar to the one we've just done. It's just telling us that this resistor has got to be 2 meg 4. What is the value of that resistor? Well, we could do that a slightly different way. We could note that because it's the same current flowing through these two resistors, the ratio of the voltage drops must be the same as the ratio of the two resistors. The same current flowing through both, so I could write the current is the voltage across the top resistor, which I'll call V1, divided by the top resistor, V1, and must also be equal to the voltage across the bottom resistor, which I'll call V2, divided by the bottom resistor, which is R2. Well, here, the voltage across the top resistor is going to be 9 minus 7.15 millivolts divided by this unknown resistor here for the current, and the voltage across the bottom resistor, V2, is just 7.15 milli divided by, we know this resistor, 2 meg 4. So we could express the answer, our unknown resistance R, as 2 meg 4 multiplied by 9 minus 7.15 milli divided by 7.15 milli. Those two millis will cancel, and that will give me 2 meg 4 times 9 minus 7.15 divided by 7.15. Great. Well, one more. Just done one like that. Let's try and find a different type of one. That's a different type of question. We want a circuit so the voltmeter would read 211 microvolts. Okay, well, we can build up a standard potential divider type of circuit like this, and you can really see there's only one decision to make in this case, which way round these two resistors will be. Well, the bigger the resistor, the bigger the voltage drop across it. If we want this voltmeter to read 211 microvolts, then we'll need quite a big voltage drop to get from 900 down to 211, but a much smaller voltage drop to get from 211 down to ground. So we'll need the bigger resistor on this side, so we can get from 900 down to somewhere below halfway, and then only 200 microvolts will go through that resistor down there to ground. So with this, the bigger resistor, this will have the bigger voltage drop. That point there will be below halfway, and that's what we want. That should do. Great. See if there's another one. We've done something like that before. Slightly more interesting one perhaps, in that we've got here a voltmeter across a resistor, but two voltage sources in this potential divider, and one of them is upside down. Remember, the long lead is the positive terminal. So at this point here, we've got minus 100 millivolts. And then we've got 75k resistor, and 160k resistor. And this point here would be at plus 100 millivolts. We want to know the voltage across this resistor. Right, what's the current flowing? Well, there's a total of 200 millivolts across both of these resistors, so the current will be 0.2 or 200 millivolts divided by 75k plus 160k. That's the total current flowing down here. If I know the current, then I know the voltage across this resistor, but bear in mind that the current is flowing this way, up through this resistor, because this is at plus 100 millivolts and this is at minus 100 millivolts, and current always flows through resistors from a high potential to a lower potential, so the current will be flowing up. The current is flowing up, then this voltmeter here is going to read a negative voltage, because this is at a higher potential than this point here. So that voltmeter is reading minus 1 times the current that's flowing. That's that value there, or I could just write x to save time, multiplied by 160k. Right, I think that's enough from me. Good luck.